is widely used in retail and e-commerce. It calculates association rules. So what it will do is it analyzes product A also bought. So a priori algorithm creates association rules. Association rules means that a person who bought product A might have also bought product. It is also frequent pattern mining. Frequent pattern algorithm. Data must be in the form of transactions or invoice. A priori algorithm helps the store managers or to store products according to the purchase patterns. So if you go to retail stores every week or every 15 days, the pattern will change. Someday you will see soaps in the front rack. Some days you will see them in the back. Some days you will see fruits and all in the front rack. So this whole setting up store is dependent on the data generated by a priori algorithm. There are three components of a priori algorithm. Refers to default probability, default popularity of any product. Refers to possibility. Lift refers to in ratio of a product when compared to. So these are the formulas for support, confidence, and lift. Support is equal to frequency of X and Y bought together divided by number of transactions. Confidence is frequency of X comma Y divided by frequency of X. Lift is support of X by multiplied by support of Y. Lift greater than 1 indicates strong association between both products. So let us say we have these invoices. These are the bills. Transaction 1, transaction 2. These are the products which are bought in those bills. Transaction 1, hot dogs, buns, ketchup. Transaction 2, hot dogs, buns. Transaction 3, hot dogs, Coke and chips. Okay. So how many times hot dogs came into transactions? 4 times hot dogs came into transaction. 2 times buns, ketchups. Then hot dogs and buns 2 times. Hot dogs and ketchup 1 time. Hot dogs and Coke 2 times. Hot dogs chip 2 times. Buns, ketchup 1 time. So different combination of products. You got the support confidence. Then we found out that hot dogs and buns and Coke and chips are bigger transactions, more number of times. So frequent item set, hot dogs, Coke and chip. Hot dogs, Coke is a chip of confidence support. So you can see here it is using these calculations. Which of the products are bought? Coke and chips divided by hot dogs, Coke, 2 by 2 into 100, 100%. The most frequent transactions is if you buy hot dogs and Coke, you will also buy. This is the calculation that if you buy hot dogs and Coke, what is the probability you will also buy? So based on that, support of hot dogs, Coke and chips divided by support of hot dogs and Coke, 2 by 2 into 100, 100%. Similarly, hot dogs, chip and Coke divided by hot dogs versus chips. Again, you can see here 100%. This is Coke and chips. Transactions, if you have bought Coke and chips, so these are the combination of transactions which are being done. So basically, when you have these transactions like this, so it will create these subsets. Based on these subsets, so we want to calculate. So if people have bought hot dogs and Coke, what is the probability or what is the confidence that they will buy chips? Okay. So what we will do is, how many transactions are there with hot dogs, Coke and chips? Hot dogs, Coke and chips, there are divided by. So that means how many of them bought hot dog, Coke and chips? 2 transactions. How many of them bought hot dog and Coke? 2 by 2 is equal to 1 into 100. We will get 100% that people will buy with, when they buy hot dogs and Coke, they will also buy chips also. So let us say people have bought, what is the probability they will buy? So same formula, but it will be hot dogs, Coke and chips divided by, denominator will change, right? So how many transactions? We know hot dog and Coke is 2. How many of them are Coke and chips? 2 by 3. 2 by 3 is how much? I think 0.667. I think 66 percentage probability is there. If people buy chips and Coke, they'll also buy. So this is how the algorithm works. It creates the cross tabulations and frequency counts of the products which are being brought together in the transactions and stores them in the memory and uses them as and when we give the. So this is the backend lift, support, and confidence. So you can see here, these are the formulas: support, frequency, and confidence and support, confidence, and lift. So this is the process behind this algorithm, a priori algorithm, which is widely used in this. This is also called as market basket analysis. This is also called as market basket analysis, MBA. Now, I have already sent you a transactions data set. Download that. Pandas as PD as NP, matplot.pyplot as %cd, pip install APYORI. From APYORI, import a priori. Now, we have the data in transactions. Each row represents a bill or invoice, the products which are bought, each row. So we are converting it into records. Records is equal to null brackets for I in range 0,7501 dot append square bracket transactions square bracket I comma j for j in range 0,20. Yes, I is rows, J is columns. Well, 700, 7,500. I have given 7501. It still says out of bounds. Okay, let us look at 5,000 transactions. So association underscore rule is a priori. Transactions is equal to records min underscore support 0.003 min underscore is equal to 0.2 min underscore left is equal to 3 max underscore length is equal to list association underscore rule. So we can see the association rules, frequencies, and probability calculations. Let's see if we can print multiple rules. For item in is equal to item square bracket 0, items is equal to square bracket x per x, items square bracket 0. You can see multiple rules here. All right, all of you got the rules? Okay, you can take your break and we'll meet after the break.
We have converted.
Previous?
In previous code we have converted rules to list now, generators to list. It is not converting.
So you change it to 5,000 only. Don't take it 7,500.
Yeah, for 5,000 also it is not converted.
Convert.
One second, I'll be.
7,500 not one. Yeah, anything less than that.
Why, sir? Why less than 7,000?
See that range, number of rules are different. If you take 7,500, it will work. Okay, all of you imported this metadata, movies metadata. So a simple recommender system, which IMDb is based on vote average, or give me your any desk number, Tapasin, I'll check.
Sorry, sir.
Give me your any desk number. Let me check this.
I need to install that application.
So IMDb weighted rating formula. This is the formula which is used by IMDb. Weighted rating is equal to average for the movie as a number from 0 to 10, mean rating multiplied by number of votes for the movie. M is minimum votes required to be on the list. C is the mean vote across the whole report.
Sir, I have provided any desk ID in the chat.
Why did you for J here? Use the right method to give. Got it?
Yes, sir. I thought in each record we will be fetching.
No. Overall. So this is the recommender formula which is used by IMDb to give the recommendations, a simple recommendation system. Now we need to calculate certain parameters here. Mean of the vote column. So if you look at the movies metadata, right? Dot columns. We have vote average and vote count. C is equal to metadata dot mean. So 5.61 is the mean. So we have to find out minimum votes required. M is equal to NP dot, or let us say M is equal to metadata dot quantile 0.90. So minimum 160 votes are required to be in the top 90%. Top underscore movies is equal to metadata dot copy dot location square bracket metadata dot equal to M. So we have 4,555 movies which are in the top category. We started with 45,000 movies, but we have come up with top movies with more than 160 votes. Now we will encode the formula which we have seen here. The top formula which we have here, we will encode it. Rated underscore rating X comma M is equal to M comma C is equal to C. V is equal to X square bracket single quote vote underscore count. Capital R is equal to X square bracket underscore average, open bracket, V divided by V plus M into R, M divided by plus V into C. So you can see the top movies which are based on score predictions. So based on the ratings, you'll get it. Top ratings, you'll get it. So you can see here, these are the recommendations. So if anybody sees this movie, you can recommend any of these movies because the score is similar to them. You can recommend any of these movies because the score is very similar to the. So we don't have rating here, right? We don't have rating here. Using ratings also we can do prediction. In the same folder, you have ratings file also. In the same folder which you have downloaded, there is a file called ratings. All of you input it, ratings.columns. So you have user ID, movie ID, rating, and metadata. What is the common column? Oh, we don't have a common column for metadata.
We have ID, no, sir.
But we don't have that ID here, no? That is ID only. User ID, movie ID are there. We don't have user ID and movie ID in. So metadata ID is this. Movies metadata, what is the ID column? I think there is no common ID, right? Is ID and movie ID same then? Okay, we'll merge on movie ID. Ratings.columns is equal to square bracket. We will change movie ID to, change the column name of movie ID to ID. DF is equal to PD dot merge metadata comma ratings is equal to, we should use PD dot concat. It's an object and into 64 columns. So ID is coming as object. Oh shit, we did a lot of full cross time. So we can't merge it like this. So we have to find out what are the common columns and then we have to merge. Yeah, credits we have ID, but what is the common column again? To mix it with ratings, to merge it with ratings, what is the common column we have?
Sir, in links.csv, we have IMDb ID.
Hmm.
But in metadata, we need to remove the TT0. So the ID will be similar.
Which is we have to remove?
In metadata, we have IMDb ID. There we need to remove TT0. After 0, we need to make all the numeric.
So you are saying this IMDb ID and ID are same, huh? No, right?
No, sir. IMDb ID and in links CSV, we have IMDb ID. There we have movie ID for that IMDb ID.
TMB ID is there 862, 884. I think this is TMB ID is the same links. I think TMB and IDA and ID are what you call matching. TMB will be 862, 8844, right? 15602. Movies data ID are same, right? We have to use links. Huh? We'll import metadata one more time because we have made a change there. Okay. So what we have to import, we have to connect metadata and links, right? Links.columns. TMB ID is the ID.
Sir, but 1,000 records are increasing now.
No problem. NS, missing values. So what is the common between ratings and DF? Movie ID.
Movie ID.
Oh shit, very bad. Okay, we'll do a content-based recommender system. So content-based recommender system. Metadata dot overview dot head from sklearn dot feature extraction TF IDF vectorizer. TF IDF is equal to TF IDF vectorizer. Stop underscore words is equal to metadata dot overview is equal to metadata dot overview dot fill any TF IDF underscore matrix is equal to dot fit underscore transform metadata dot overview. TF IDF matrix dot, okay. So we will use cosine similarity. Similarity will be used for identifying. So this is the formula for cosine similarity. sklearn dot matrix dot pairwise linear underscore kernel cosine underscore sin is equal to linear underscore kernel TF IDF matrix, comma TF IDF matrix. Indices is equal to PD dot series metadata dot index. Index is equal to metadata dot drop get underscore recommend, comma cosine underscore sin is equal to cosine underscore sin IDX is equal to indices dot sim underscore scores is equal to cosine sim square bracket IDX sim underscore is equal to sim underscore scores comma key is equal to x colon x square bracket 1 sim scores is equal to this object has no attribute title. This is we have a problem. We have title in indices. Why story is there? Huh? Once you create the TF-IDF matrix, you have to do cosine similarity. You have created TF-IDF matrix.
Only application of because we
అయిపోయింది